Here is the question, matrix, a 2 by 2 matrix, very simple matrix, and our objective is to find the eigenvalues and eigenvector. Okay, the first step here is to write a characteristic equation. Okay, first step is to write the characteristic equation, and that will be written by this way: the determinant. So you will write the determinant and write all the values. Okay, excuse me. So whatever the matrix you have been given, write that matrix with the determinant, and from the diagonal, from the first diagonal, subtract with lambda. Okay, and put equal to 0. So that is called the characteristic equation. So you will be writing your given matrix in determinant form by subtracting lambda from your diagonal. Okay, by subtracting lambda from your diagonal. And after that, we already know how do we solve the determinant. Okay, so we multiply diagonal, minus minus plus, minus will remain the sign. The same process of solving the determinant we have already done in chapter number 2. Okay, and then here is some sort of characteristic equation is there. We try to solve this equation. 1 multiplied by 1 is 1, lambda multiplied by lambda is plus lambda square, and minus 2 lambda minus 1 equal to 0. Okay, we are solving this by multiplying. This will be cancelled with each other. So lambda square minus 2 lambda equal to 0, and lambda minus 2 equal to 0. So we are getting two values of lambda. Okay. So what you are looking here is called the eigenvalues. So these are called the eigenvalues. The first step is completed. Okay, so it means that the first step is basically the application of determinant. We are applying the determinant concept to get the eigenvalues. And in the next step, what we'll do, so we will write two matrix. One of the matrix will be written by this eigenvalue, and another of the matrix will be written by this value. So now we are moving for eigenvectors. Eigenvectors. So eigenvector for lambda is equal to 0. For lambda equal to 0, first eigenvector. So what we are going to do, again, whatever the characteristic equation you have written in the determinant form, now write that determinant in matrix form. Okay, and you have to put the value of the lambda inside wherever the lambda is used in that characteristic equation. Okay, so lambda is 0 and 0, it means that 1 minus 1 minus 1 1. So by lambda in the characteristic equation we remain with 1 minus 1 minus 1 1. Okay, and you have to write C1 and C2 and then equal to 0 0. So that is the way we try to find the eigenvector. So we have written this matrix by writing the values of the lambda inside. Since lambda is 0, so the matrix will remain the same, and C1 C2 and equal to 0. And from this part we would write the augmented matrix. Okay, augmented matrix is 1 minus 1 minus 1 1 0 0. Okay, basically it's a system of linear equation. That's what we have seen in chapter number 1. Okay, now we'll try to solve this matrix by row operations. 1 minus 1, 0, 0. So that's what we have found by row 1, row 2. Adding row 1 with row 2, we got this one. 1 minus 1 is 0. If we add 2 rows, we'll get 0. Okay. That is what we have done in chapter number 1, row operations. So from here, this will be written by C1 minus C2 equal to 0, isn't it?
Yes.
Okay, and C1 equal to C2. So it means if C2 is equal to T, then C1 equal to T. So it means that C1, C2 equal to T and T, which is equal to T outside 1, 1. So that is called the eigenvector. Okay, that is called eigenvector. So basically solving a system of linear equation, and after that whatever you are getting, it is called the eigenvector. Okay, and now we have to find the eigenvector for another eigenvalue. So another eigenvalue was 2. So now we are moving for eigenvector for lambda is equal to 2, and again we have to put the 2 in the same characteristic equation.
1 minus 2.
So 1 minus 2 minus 1 minus 1 1 minus 2, and again C1 C2 and 0 0. So this will remain consistent for all the situations, 0 0. Okay. So 1 minus 1 is minus 1. So 1 minus 2 is minus 1, minus 1, minus 1, minus 1. C1, C2, 0 0. Okay. Now we are proceeding to write the augmented matrix. Minus 1, minus 1, 0, minus 1, minus 1, 0. Separating by dotted line. Again, the leading element is minus minus and 0. Minus 1 and 0. So we'll multiply row 1 with minus 1 to get 1 1 0, minus 1 0. So again we will add both of these equations. We'll get 0 0 0 by row 2 with row 1 by adding. So it means that C1 is equal to, or C1 plus C2 equal to 0. So it means that C1 equal to C2 minus. So if C2 is equal to T, C1 is equal to minus T. So it means that C1 and C2 equal to minus T and T. So T will be outside, so minus 1 and 1. So that is called the eigenvector. Okay. So eigenvalues and eigenvector question is completed at this step. So after writing the matrix K, we have written the characteristic equation, that is called the characteristic equation. Now solving 3 multiplied by 2 is 6 plus lambda square minus 3 lambda minus 2 lambda minus 20 equal to 0.
We expand the bracket, right?
Yeah?
We expand the both brackets.
Yeah. So by solving lambda square 5 lambda minus 14 equal to 0. Okay, so I'm convenient to apply the factorization. So plus 7 minus 7 lambda plus 2 lambda minus 14 equal to 0. Lambda minus 7 plus 2 lambda minus 7 equal to 0. So lambda plus 2 lambda minus 7 equal to 0, and lambda is equal to minus 2 and lambda is equal to 7. So these two values are the eigenvalues. So that is how we would be writing. Let me write here minus 2, 2 minus 3 minus 2, 4, 4, 5, 5, C1, C2, 0, 0. And now we are moving towards augmented matrix. 4, 4, 5, 5, 0, 0. Okay, so what we could do here, multiply row 1 with 1 over 4. So 1, 1, 0, 5, 5, 0. So what will be the second operation? Row minus 5 multiplied by row 1 and will be added to row 2. So 0, 0, 0. Okay, so we got C1 plus C2 equal to 0. So C1 equal to minus C2. So if C2 is equal to T, then C1 equal to minus T. So C1 and C2 is equal to minus T and T. So taking out T, minus 1 and 1. So that is called the first eigenvector. Okay, and then for lambda is equal to 7, because the second value is lambda is 7. We have to write again the matrix 2 minus 7, 4, 5, 3 minus 7. Okay, 2 minus 7, 4, 5, 3 minus 7. So we are remaining with minus 4, 4, 5 and minus 5?
Yes. 2 minus 7 is
Minus 5. Minus 5, and here we got minus 4. Okay? C1, C2 equal to 0, 0. C1, C2 equal to 0, 0. Okay? And now we will write augmented matrix. Minus 5, 4, 5, minus 4, 0, 0. This way. Clear? Now what we have to do? So I think if we add if simply we add two rows, there is no need to multiply or subtract, because by adding we are getting minus 5, 4, 0, 0, 0, 0. That is the most simplest thing. There is no need to add or subtract something, because when you add these two, minus 1, minus 5 and 5, you will get 0. 4 and minus 4, you will get 0. So there is no need to, complicate the question. And we are remaining with minus 5 C1 plus 4 C2 equal to 0. Okay? Now we just need to simplify. Minus 5 C1 is equal to minus 4 C2. So minus minus cancel. So C1 is equal to 4 by 5. 4 by 5 C2. Okay? If C2 is equal to T, then C1 is equal to 4 by 5 T. So it means that C1 and C2 equal to 4 by 5 T and T. So answer is T is outside, 4 by 5, 4 by 5, 1. So that is the second eigenvalues. Sorry, eigenvector. Eigenvector. Okay. Yeah, you can check here. Yes. V is equal to 5, 4. It's fine. The vector is fine. It's written 4, 5. So it's fine. There's no any problem. Okay, 4 by 5 and 1, it's the same thing. And you could test as well. Testing. So where A is your matrix, whatever the matrix you have been given, so we are considering the left hand side. So what was the first matrix? The matrix we have been given A. So multiply these two. So row with column, 2 multiplied by 4 by 5 plus 4 multiplied by 1 and 5 multiplied by 4 by 5 plus 3 multiplied by 1. That is the multiplication. We already familiar with that. So 2 multiplied by 4 is 8 by 5 plus 4. So 20 by 5 plus 3. So 8 plus 20 by 5 and 20 plus 15 by 5. Okay. So it is 28. So 5 will be out. So 28 over 35, isn't it? So can we write by this way? So 8 plus 20 is 28 20 plus 15 is 35, and in both of the numbers 5 is the denominator, so we'll keep 1 by 5 out. And from here we simply trying to have the 35 can have anything common, so it should be 7, yes, 7
5.
5. Yeah. So for example, if seven is out, okay, so this is the eigenvector you have obtained. Okay, this is the eigenvector you have obtained, and this is the eigenvalue. So you have lambda and x, so this is your x. So it means that by starting we start from so this is only the testing. So testing I'm just doing for you, so I don't need any testing. So here is the equation, ax is equal to lambda x. So if you have found any eigenvector x and you want to test that if it is a really an eigenvector, so you multiply a with eigenvector, so you will get lambda x, mean the same eigenvector with your value of lambda. So at the end you could see that with the same, we have eigenvalue and corresponding eigenvector, so they are multiplying with each other, lambda x. Okay, so that is the basically testing criterion, that whatever the working we have done, it's correct. Okay, so sometimes they might be, you could see the eigenvector may not be the way you might be expecting, but if your working is correct, the way we solve the questions, if your working is correct, so be sure that your eigenvector is correct. Okay, otherwise if you have doubt, then of course you can test always.